In this video, I want to talk about the notations that we are going to use to define the problem of binary classification. Specifically, I want to talk about feature vector, what is a feature vector, and how to represent the feature vector using a mathematical notation. I thought it would be a good idea to explain these concepts by taking an example of a picture of a cat. And the thing is that this picture of a cat is actually an arrangement of rows. There are going to be columns in this picture. These rows and columns actually store the color with their intensity. We have the intensity 2. This means the brightness of the picture or the composition of colors here is of value 2. Now the thing is that why do we need notations? It helps us to define our problem in a more concise way. So instead of just defining our problem using these boxes and arrangement of rows and columns, we're gonna be using some kind of notation that is going to represent, that is going to translate what our thoughts in a more concise way. And the other thing is that we want to have some kind of notation that is gonna be more closer to the language of computers. Mathematical notation means I'm going to be using the concepts of mathematics to write my problem in a way that would be more closer to the computer. So let me take an example. Up above, we have this picture of a cat. Now in mathematics, we have something called a column vector. It's a matrix having just one column. To translate our picture in a mathematical notation, we're going to use the concept of column vector to represent the picture of a cat. How can you do that? So it's going to be easy. So what we have to do is that we have to define a column vector. So let's say the name of my column vector is x. Then we call that object that we are interested in x. Now what I'm going to do is that I'm going to store each of these values over here. Each of these values in each of these boxes, I'm going to copy all of these values in my column vector. So let me do that. The other thing about this column vector is that what would be the dimensions for my column vector x? That dimension would actually depend upon the picture over here. In our case, in our example, we can see that we have 16 boxes. Each of these boxes have values defining or representing the intensity of the color, and we have to store these values in our column vector. So this means that we need to store 16 values. So in our case, our column vector x would have 16 rows. 16 rows and one column. But the standard way to write this down, is something like this. So x belongs to a space where we have 16 rows and one column. 16 times 1, 16 rows and one column. That actually what I did over here is I have represented, if I could just go up, I have represented my picture and the values in this picture using a column vector. Now finally, this column vector over here in mathematics is called column vector, but since we're going to talk about machine learning or deep learning, we have a more specific way. We call this feature vector. And the reason we are actually storing the features of our picture. The picture of a cat would have eyes, paws, fur. What would you call those things? You would call those things feature of a cat. And how do you represent those features? You are representing those features in this picture. You are representing those pictures are actually encoded using colors, and those things are called the features. Maybe this color intensity over here would be the color intensity of the ear of the cat. This color intensity over here would be the color intensity of the nose of the cat. Over here, the fur of the cat, the paws of the cat. So that's why this is called the feature vector.